Good morning, ladies and gentlemen, and welcome to day 2 of the 4th Milsatcom Middle East Conference. Welcome back to those of us that were here yesterday, and welcome to those who are attending the conference today, joining us. Again, an exciting day of and lineup in terms of panelists, themes that will be addressed today. We will start this morning with the first panel session, discussing interference in the satellite domain, jamming, and many other topics that are of interest to all of us. The panel will be managed this morning by Martin Coleman, who is the Executive Director of the Satellite Interference Reduction Group. Since taking on the position in 2011, Martin has been active in spearheading a number of significant initiatives, including a campaign to introduce carrier ID across all SCPC transmission since the 2012 Olympics through being fully ready to implement by 1st January 2015, so just as we speak. Martin regularly addresses the industry on the subject of satellite interference at global industry events on an individual basis and at the sIRG annual conference. Please welcome Martin Coleman.
Okay, good morning, and thank you for that welcome, and thank you to SMG for making this all possible. Before I introduce our panel, I'm going to try and set this scene. It's interference. It's not a good word, really, but you know, we do have a fantastic industry. But we've got to get some of this in perspective. I also have apologies from a great friend and colleague, Yasir Hassan of Arabsat. He was unable to make it, so I'm going to take his place a little bit because Yasir works very hard for the group in making it possible to get some of these initiatives through. And we've got some slides here, we've got all sorts of things here, and they'll all be available to you at the end. We'll make sure of that through Anna and the guys at SMG. So don't worry about what you might miss. The panel will get you there. It's a big subject, very big subject. I heard a lot yesterday. Now I think it's time we put the facts and figures in front about what interference is, and especially this horrid one called deliberate jamming, the intentional. But let's think about this for a minute. Let us, when my phone with the notes actually does what it's supposed to do, and they say an iPhone is wonderful. As I said, we have a great industry. It's fantastic for all of us. Things are getting better, we get growing, growth is fantastic, satellites are getting bigger, capacity's growing, high throughput. Trouble is, we add to all this that we want everything faster, quicker, cheaper. There's the rub. There's the sort of the problem. That's where it starts to go wrong. My colleagues will help us out soon on this. We have simpler terminals. In fact, domestic terminals that transmit to satellites, VSATs, all sorts of SATs, any SAT. The point is, we want all this, but our eye is slightly off the ball, has been off the ball. In other words, we're just off target. We're not looking at the quality enough. We're not training people to manage systems. Sometimes I look at system design. We're not even designing systems. The common sense isn't there. We have to be careful. My colleagues will help us try to understand that in the short time we have. It's a very big subject, and welcome. I'm sure if we don't raise questions right now this morning, you know, it'll be on our minds and lots of things. But we need to try and get this subject put to bed and put in its right place. Because at the end of the day, two things. One, all interference is harmful. Full stop. The other problem is what we may look at deliberate and the intentional. The sad part is it's us that cause the interference ourselves. The industry is its own perpetrator of the crime of interference. So we have to get better. And that's what this group has been about for a very long time, a very small engineering group. And as I say, I'm going to start us off with where Yasir would have brought us in on behalf of this region and the other satellite operators of this region, because I believe, as we're starting to see in Asia, that we have Arabsat, we have Yasir, Eutelsat, and others. We could form a very great group here of this area to help beat the problems down that we sometimes face, and this area has faced some, as we well know. So, some of the thing about Arabsat is just a quick glance at the company. Most of you know it well. It's a very respected company in the area, and as I say, Arabsat in particular have really taken to heart to try and solve interference. I'm going to move on here quickly into the mitigation that we wanted to do, because here we've been seeing recent events. You know, we do have some political problems that have created what is quite a rarity, deliberate jamming. People like Eutelsat and SES actually have 0% intentional. But our colleagues, possibly here in this room, certainly Eutelsat and certainly Arabsat, work together. There's another important factor that will come up into this conversation. We have to be together. Have been badly affected by services. And I think Andreas, and I will introduce Andreas properly, but this is typically commercial deliberate jamming, not military. It's quite an important point. It's actually affecting commercial things. That's the real target. But what I wanted to do is gives you some idea. We've been over the peak, I think, at the moment, but it's still there. You can see there from the statistics, you know, some 24% of Arabsat's problems in 2012 were deliberate. This is exceptional. But I don't want us to focus that way. Deliberate is a form, and we will discuss this and what we're doing. We've made many moves as a group and with our other groups out there. And one of them being GVF is a very big pusher of initiatives, training, quality, and helps us make things like carrier ID possible. And that, of course, leads us to people like the ITU and shows and events as this is. But one important thing here is ASBA, the Arab Satellite Broadcast Union. They've come up with this plan, action plan, and one of the things in there is carrier ID. But also one of the things in there is about dealing with the deliberate jammer and putting more strength, putting some bite behind what are quite weak powers when it comes to political problems. It's very difficult. And certain decisions last year in Brussels have been made that are starting to make it possible to start dealing, once we've found the deliberate jammer, what do we do next? I just want you to remind you that it's going on all the time. A lot of people are working very hard at this. And I have to say that the harder we work and the cleverer we get, especially at engineering level, we do depress this subject. We fix it. Interference is starting to be contained on all fronts. That is happening now. The services are growing, but interference is staying steady. What we don't want is that growth of our services and growth of interference. There's a lot of work to be done. So, without further ado, I'm going to introduce our colleagues, and so that we can move on and get things going. I'm going to swap presentations now because I'm going to bring some people. But my first colleague, Andreas Voigt of Eutelsat and fellow director of IRG. If you'd like to come up, Andreas, please, and you can carry on, and we'll get Eutelsat's perspective on this particular subject of the deliberate jamming before we move into the more practical. I'd like to welcome my colleague Roger Franklin from Crystal. He takes us down a practical route, and this man single-handedly got together with people like Comtech and effectively invented the new carrier ID. So thank you, Roger, for that. It was a great effort. And two other colleagues, and we have a real mix in our room of engineers. We compete with each other and everything. But do you know what we do, actually? We sit in rooms and work together. My next two colleagues, Erwin Greilinger of Siemens and Terry Belange of Zodiac Aerospace. Two great competing companies. They're well specialised in carrier monitoring and geolocation and other wonderful subjects that we'll hear about more. So bear that in mind. So just while we swap things over, I'm just going to get Andreas ready. So I'll start you off. So Andreas, oh, here we go. That's a good start, isn't it? Do you want to see all of this in one go? Right, sorry about that. We're at the wrong end of a presentation. Andreas, would you like to take us from where Yasir would be today, where Eutelsat is with this subject, and take us into the realm of deliberate jamming, and then perhaps lead us back out of the dark and into the light? Thank you, Andreas.
Yeah, good morning, everybody. I will have a look, first of all, at our site, how we are working. As head of the interference control group in our worldwide control center, I'm in contact with interference resolution and analysis and restoration of services every day. My team is working 24/7 on that. Whenever it's necessary, we are there to help our customers, together with the work of our control center. And for sure, this is going to be one of our first slides. First of all, to have a look through our monitoring facilities. Next, please. We have a core network of 23 monitoring stations worldwide, based on the ZCAMS architecture from the company Siemens. And we are monitoring our RF component and space capacity in fore and background worldwide, and wherever necessary. We have mobile measurement solutions ready to implement when our business is growing in some areas where we have no measurement at the moment, so we can put it into an airplane, build up the antenna there, and do the measurements whenever necessary. With regards to the deliberate interference case, would like to give that message here from Eutelsat, that Eutelsat takes it potentially deliberate jamming as extremely serious, and we are working together with other entities to combat this jamming. Technology, collaboration with the ITU and the satellite community, for sure, also with the national regulators, is key in this. We have to admit that we have the deliberate jamming as interference type, but very rarely. So we are not getting over 10% of all cases by far. In the last years, we had 1 or 2%. So, and we have to say, this is not hitting any military services. It is on DVB, direct-to-home TV services, where we can see it. So, however, as we take it so serious, we have a very high success rate in geolocation. That means in identifying where the actual interferer is coming from, and therefore we are able to talk to the authorities about it, make the necessary filings, and go ahead with the escalation proceedings. Other interference cases include technical human error. This is approximately 70% of all of the cases. So examples are high transmission of EIRP, cross-pole introduction, wrong satellite pointing, or also when the user puts wrong transmission parameters into the thing, or transmits via the redundant chain on a non-used or non-intended frequency, just a double transmission. I have some examples on the next slide, where you can see on the top left somebody transmitting so much power that you can not only see the third order intermodulation, but also the fifth. So it looks a bit like a tree rather than a carrier. On the right side, somebody is transmitting or retransmitting something which has been received from another satellite. Unfortunately, he forgot to filter out the transponder 70 megahertz basis, so he is transmitting 5 dB of noise into the next transmission chain. On the lower left side, somebody wanted to come up in the middle of the carrier arrangement, but unfortunately, it did not put a symbol rate of 2 megasymbol, but unfortunately 20 megasymbol. So the carrier looks a bit low, but as you can see, it damages and degrades at least 5, 6, 7, 8, 9 services. And the classic one on the bottom right, cross-pole. Most of these cross-pole interferences we see today from automated uplink antennas in SNG areas where engineers are no longer sent to show cases, but journalists. They press the green button, and if something goes wrong, they don't even have a solution. So they transmit with the cross-pole, we call the station, and they say, oh, I actually don't know what to do. So there's a bit of training necessary, but not only training of the person who is using that, but also training of the industry of that transmission system to have a very clever and very low profile architecture available to prevent that export. A homemade one, adjacent satellite interference. Why do I say so? It is not only the user who does errors, but it's also the satellite operator. We need cooperation between us. We have to recognize that C-band, KU band, and also upcoming KA band will be very tight in satellite spacing. So, whenever we have satellites with distances of 1.5 to 2.5 degrees in C-band or in KU band today, it is a problem, because no matter what kind of VSAT we have in the field, we need to go ahead and recognize that this VSAT is not transmitting only on one satellite, but maybe on 3, on 5, because of the size. We have learned at the exhibitions and the conferences that the VSAT antennas are going smaller, more powerful, as well clear with spread spectrum technology that the carrier is a bit lower in power. However, it is still visible all over the place. So we can see it here, for example. On the left one, we can see an empty transponder put into max hold, the purple line, and above the adjacent satellite. And you can see very clearly that even the spread spectrum signal on the right side, where we have the tiny little knobs transmitted on the operational transponder, it is leaking through a distance of 1.6 degrees. This is an aeronautical system. And for sure, as you can imagine, aeronautical mobile systems are 80% military based. So we have a problem here. We need to sit together and we have to think about how we are able to resolve that problem. On the left side, we have a maritime mobile service. Internet connection to cruise ships. These things are 1.2 meter antennas, but the ship is moving. Sometimes the positioning software of the mobile antenna is just not good enough, and therefore it leaks through. Just think about in the lower transponder, you would like to have a UAV service, you would like to have a secure internet connection to your headquarters on this transponder, and you will get a bit of interference into it, you would consider it harmful. But at the end then, you might learn that it is your colleague who is not wearing your blue uniform, but maybe the green one, who is producing it. So that's why Eutelsat has quite a unique idea here, because we would like to put the people together on one table to talk to each other. As you can imagine, we have a lot of customer bases from the United States of America, and we are working directly with our brand filiale in Washington with it, who are able to speak to the necessary people, and we have quite a high success factor in resolution. We might not hear anything about it at the end, but the interference is gone. So that is what it takes care. Interference is harmful. We are here to resolve the problem. And time to solution matters, not only for you guys, but also for us as satellite operator. Next one, equipment failures. It's clear something can break, like a cable, like a connector, mispointing of automated antennas, we already spoke about that, failure of software changes and whatever. So, but one thing is quite impressive. We're coming back here to the point that we have identified VSAT terminals as the cause of most of the cases. GSM transmission, for example, because a VSAT antenna has been installed on a petrol station 10 years ago under the sun of the Arab Peninsula, for example, here, and the ultraviolet light corrodes and degrades the coaxial cable so much that it disintegrates, and there is a GSM transmitter just next to it, transmitting on the same intermediate frequency range as the indoor unit of the VSAT does. And suddenly we have a 10 or 20 dB carrier next to the VSAT service from the GSM base station as the beacon of that BTS is translated directly into KU band and transposed on our transponder to produce interference. Power control issues are there. So here's an example, or better to say 3 examples of these equipment failures. On the top left one, we have every 20 megahertz a peak because an up converter decided to give up its life and to send the 10 megahertz synchronization impulse all over the transponder. The picture below shows GSM modulation, which is quite significant in slots of 200 kilohertz. Looks a bit like a cupola or half a circle with a tiny little spike on the side. And this tiny little spike is very typical for GSM modulation, and everybody can identify it with this very easily. We decided then at Eutelsat that we would like to contribute something, and I selected a company to produce a GSM demodulation tool, which we have now installed in our system, and as contribution to the industry, we gave that tool and contact to all of the members of sIRG as offer available, that every member of sIRG can actually purchase that without the development cost, because Eutelsat has committed itself towards the industry to take that cost, and as well as, for example, SES did with the VeriSat development for the VSAT case. On the right side, we can see also quite a nice one in brackets, which is a failure also of an up converter producing a sweeping interference, and you can see in the waterfall diagram below how over time that carrier transmit, then stops, and suddenly comes up on a completely different frequency, crashing for some seconds while it's sweeping through other services until coming to a rest once again at that frequency. So my conclusion, there are 2 things. First, fight interference. Absolutely clear. Restoration of service, the prime target of all operations whenever interference happens. And The second one, cooperation is key between customers and control centers, because the customers are actually the ones who are operating the antennas and the networks, 100% clear. They are actually touching the equipment. We at the control center, we can give advice, but we can't travel at the same time all over the world and solve the problems what the customers provoke. And whenever we have adjacent satellite interference, we need to speak to the operational center of the other satellite operators. That means, as much as I talk to my team for geolocation assistance, interference analysis, and technical solution finding, I'm also on the phone with our colleagues in Ellenwood, Georgia, in Eutelsat Control Center, or in Betzdorf, or in Woodbine, from our SES colleagues to fight, identify, exchange data, and identify at the end, for the sake of all of our customers, and remove the necessary things. That means also that we have to have a very nice and fully stacked toolbox. Use all the toolbox tools which you have. Open your box and select the right one. It needs technical experience. It needs technical know-how. However, without the tools in your box, you lose time. And once again, time to solution is the most critical thing in interference resolution. Last point, preventing interference. Like sIRG says, it's a sin. Stop it. So, therefore, let's have a look. What can we do? We can for sure enhance our toolbox, but we must not forget about situation awareness on all levels. That means in the control center, I have to take care that my control center guy can identify interferences, what they are, faster, better, and more thorough. I need to make sure that our company, together with sIRG, together with the Global VSAT Forum, together with other entities, are going to the customers and explain about pointing antennas, how to operate. But that's not the last point. It is also how to operate VSAT network management centers in these days, because they have so many tiny little options. Vendors of this kind of equipment do not pass the message at the moment, and if it is operated in a state that might be a bit not so well for the operation itself, it can provoke interference and disturb services. So I conclude with that. Martin?
No, thank you, Andreas. Well, Andreas has tried to set that scene from the satellite operator. I think he set it well, and on behalf of our colleague Yasir as well, because Yasir would be right here, right behind, right with, not even behind Andreas. The point is that an interesting fact, I need to go back here, and we will move on. It's all right, don't worry. I'm looking at the clock very carefully. The interesting point is here that the engineers always used to work together anyway. It's just we never knew that. You never knew that competing satellite operators actually, for years and years, decades, have always had to work together, because solving problems is the only way to solve the problems. I mean, Andreas often tells me he's often in touch with his colleagues in SES more times than his own colleagues, because that's how it works. Collaboration, working together, whatever you call it, cooperation, it's needed. And I'm glad you mentioned situational awareness, because all of our colleagues in most of the satellite operators in the IRG are members of the Space Data Association. Now, yesterday we heard, I was really interested about the EU Satellite Centre. And again, situational awareness of our environment, space itself. I'm going to quote you something. We're working very closely, and let's bring a little military flavour back to this. We're working very closely with the DoD. In fact, some of our colleagues there will be joining us at a workshop in Washington, and anybody who's at the satellite show, take a look at your diary, because at the end of that show, we have got a full 1.5-day workshop That's not an advert because of us and IRG. Oh, you're welcome. Please come. Listen, there's a lot to be said. There's good people in the room. But the point is, here's what the DoD think through one of their working groups that's looking at, guess what? Carrier ID for military, it's going to happen. It's already started the processes of how to do it. And we'll look at these tools and initiatives in a minute. That's what my colleagues are going to do here in a second. We're going to get into that practical side. But here's what they say, quote, approach protection like we are at war in space. That's a pretty strong statement. And they mean it. Yesterday we saw the classic, what our planet looks like if you try to look through all the satellites. It's a busy spot. My warning is the SDA is already into that global gathering data. We're going to talk a little more about data. It's so much subject matter here. It's a lot. But the SDA is already there. I always worry about our colleagues in Europe and elsewhere. Europe, if you look on that globe, Europe is just a continent. It's a pretty small continent. And when you look globally, we're all quite small. The only way we're going to solve our environment if we want to keep it free and usable is we have to look after that environment together, globally. A continent, a superpower, a country cannot go it alone. These guys in the satellite operators, if you like, are part of that process of looking after that environment. They do it every day. But they have to work together. And I urge our colleagues in ESA and everywhere else, we talk to ESA a lot, and I'd like to talk to the EU Satellite Centre, that we need to join this together. We already work with JSPOC. There's, is it ComSPOC from AGI? Is that what they call it? There's a new one? Yeah. Yep. There's work going on, but it's all interlinked and people working together. That environment is getting busy. What is it, Iridium, 68 satellites coming up soon? And yeah, then Roger, you said there was another 400?
Well, Web 1 is on the drawing board, and they're going to have about 400 satellites. And SpaceX is looking at their own low Earth orbit system with up to 4,000 satellites. It's going to be a lot of activity going on up there, and making sure we don't step on each other is extremely important.
So while I swap presentations around again, because this is going to be exciting here today as we move around and start to bring us towards the more practical approaches of what we're doing. Let me just get going here again. Okay, we've covered the deliberate jamming. I'm going to move through here a few slides. This is pretty typical of the interference puzzle. It's a very simple look at interference, and yes, you can see there's intentional in there. But my goodness, can you see what it really is in there? The technical error one, my goodness, that's us. That's us, the industry. Lots going on. Oh, the slide has moved. Look at the minutes that were lost by Eutelsat. These are some statistics, real statistics from Eutelsat about the losses when a deliberate jammer comes in. But again, it's peaky. But what I also want to say is I don't want complacency. Just because our colleagues here and Eutelsat are being affected by certain parties and deliberate jamming, our colleagues that are not being affected are working with them also to solve and get the toolbox. And I mean, Andreas, I think you said you were very proud the other day to do a geolocation. You found someone in 8 minutes.
Yes.
Now, this used to be months and days and years and whatever. And we'll get into this in a minute. This is fun, because one day it's going to be 8 seconds. So whoever wants to do any jamming will be on your case very fast. We may even know who you are before you begin. There is so many good techniques. The engineers are getting smarter, and we will not be beaten. It will be fixed. And guess what? We can fix everything else while we're at it, which is even better. So I'm going to start us to go towards the more practical now. We've talked about situational awareness, we've talked about the global strategy, we've talked about the working together. So I'm going to let Roger introduce who he is, Crystal. He's bringing a more practical element to this. Been involved with carrier ID forever. does monitoring and everything else. I'll let him explain. But it's a slide here that I want to start us off and lead us into technology and what we're doing. So Roger, please.
Thank you, Martin. I'm Roger Franklin. A brief introduction about me and my company, Crystal. Crystal's been in business for close to 30 years, and we focus on monitor and control network management systems, presenting our users with a nice, clean dashboard that makes it very easy for them to keep an eye on their network, understand what's going on. We add a layer of automation to increase the resiliency of these systems for each and every mission, to make sure that when equipment failures do occur, that our customers, our users are protected and their networks continue to operate. Part of that automation system looks at things like if an antenna is in motion and you're transmitting through that antenna, then the transmitters need to be shut down. It's amazing how many systems are out there where that link between the transmitter and the antenna motion is not established. And from early days in the late 1980s, when customers would simply move an antenna at the click of a button because it was so easy, not realizing that they were transmitting through that antenna and happened to spray the arc, and then realized what they did and move it back and spray the arc again. Building those systems that are smarter and can compensate for some of the human errors that occur is extremely important to Crystal and our customers. The final component of what we provide, since we are communicating to the network equipment, being able to record the data that equipment is telling us, run reports, analyze those reports, and provide some intelligence so that proper business decisions, more effective bandwidth purchasing decisions can be made, audit capability to understand what actually did happen when a problem occurs. Was it human error? Was it systems error? Was it something that was outside of your control? Being able to provide that information to our customers is very important. Go to the next slide. As we look at interference, we can kind of categorize the satellite user community into these three major groups. And I assume that most of the people in this room fall into the first group, where we actually care about preventing RF interference. And these are the folks that are willing to take the carrier ID standards, implement it, turn it on, even in military applications, understand that it's a good thing. And I think we said last night, or heard last night, that about 50% of the interference in military environments is caused by the military themselves. And being able to quickly identify those sources by extracting carrier IDs, using tools like Verisat that can identify VSAT sources is important to this community. The second group is a hard one to deal with. These are folks that simply don't care about RF interference because it, quote unquote, doesn't affect their network, or they can't generate a business case for dealing with it. If you've been in the industry as long as a lot of us have, you understand that the cost to ensure initial quality more than pays for itself in the long run. And being able to provide intelligent VSAT remotes that are less prone to retransmissions, that understand that when you move an antenna that you need to shut down transmissions, being able to understand that there's no point in transmitting until you have a good receive signal. And the default mode should not simply be, let's increase more power to hope that the hub system can hear you. It needs to work the other way around. The remote needs to hear from the hub before it goes out and starts transmitting. Reaching out to those people and helping them understand that smarter, better systems with higher quality result in better networks for them, better networks for the community, and less interference overall, which is a very good thing. The third group are those that actually do want to do harm. They intentionally try to disrupt other services. As Andreas said, we've seen that much more in the commercial environment than we have in the military environment, mostly due to political reasons. And I think there was a gentleman yesterday that said that the solution to those are A, political, B, military. So either you disrupt their ability to transmit through political pressures, or you simply take out the transmission site. Gentlemen in the room have the capability to act on the B. Most of us shy away from that particular solution.
Yeah, I think Roger's got a point there. I mean, and remember what I said earlier. And Andreas, if you want to correct any statement here, please do. But I mean, Andreas pointed out to me or us yesterday that this deliberate is actually affecting commercial services, not military. In the military, it's often the tactical and it's more specific in when there is real conflict. It's a different animal, and as Roger alluded to there are ways of dealing with that. In our commercial world, we only have ITU, which is basically the UN. And we all know, for us as engineers at the bottom of the tree, as it were, I'd like to think we're at the top really, but let's just put us in our place. It's very hard. We can find people, we know who it is, we know where they are, we know everything. But you can't stop it. That's where the political side comes. That's hard. But something on that slide there, proving things, providing evidence, what's that? Now, it's a very good lead into our two colleagues who are some of the best geolocation people here around in the planet. There are one or two others, but they're pretty good, these guys. We're going to move into that subject area of finding things, getting tools and that, and including we're getting a little bit of detail about carrier ID as well, just to remind the audience of that. But getting evidence, one simple thing that occurred to us, that if geolocation systems reported in a standard format, evidence could be provided to the ITU, written evidence, timed evidence, coordinated evidence, and you just simply lay that down and you put it in front of the people that can perhaps fix it, and that has an effect. The better the evidence, we can have our way. Remember, this is the only type of tool the commercial area has, is to get to the ITU. That's the last move we can make. But in the meantime, yesterday people mentioned technologies on satellites, what we can do there. There's a lot of things going on here, and I want to start that discussion now, start moving into technology. So I want to bring Erwin in at this stage, and it's up to you. You can either start in the dear subject of geolocation and get into that, or you could go into the new things. I leave it to you, sir. But we're going to let Erwin start here, and we'll get Terry to follow as well. We've got some slides here on certain parts of the system. Some of that will help understand what geolocation is. It's a tricky subject in its own right. But Erwin, take us on further into where we're going with this.
Yeah, thanks, Martin. Let's first briefly introduce myself. I'm product line manager and sales manager at Siemens for satellite monitoring and geolocation systems. We are dealing with that since 15 years. We have a product called SICOMS on the market. We are working closely together from the beginning with Eutelsat. So basically our system was developed based on requirements from Eutelsat. But in the meantime, we have a broad range of customers, of different satellite operators all over the world. 3 weeks ago, we could successfully sign a contract with Arabsat, so they will also use our system. That means 2 of the satellite operators which are heavily affected by interference are our customers, so we have a quite good expertise in this area. As we could see from the presentation from Andreas, satellite operators are affected by different interference cases, and all of them have their own challenges to detect them, to analyze them, to localize them, and at the end to get rid of them. And therefore, he requires to have a toolbox available in order to have the ability to fight against these interferences. And today, we have these tools available, which has a quite good success rate, but we are still not at the end of the road. Our engineers have quite great ideas to develop further these tools, to develop new methods, new algorithms, to resolve more cases which cannot be resolved today. And I would like to give you a few words on where we are standing and an outlook to the future, where we are going to. Today we have carrier ID implemented, so that's from technology point of view no issue anymore. Carrier ID will not help for deliberate jamming for sure, but most of the interference cases are unintentional, and for that I think carrier ID is a major step in resolving that. We have geolocation systems on the market which works with a quite good accuracy and a good success rate. There are around 4 or 5 real good working systems on the market, I would say. And all of them are using the basic methods, but for sure on top there were some quite differences. But these geolocation systems, all of them have the drawbacks. I mean, they are requiring to receive the interference signal from at least 2 adjacent satellites, which have to be close together in order to have a significant crosstalk on the other satellite. They require to receive the signal in the same frequency band. You need to know the exact position and velocity of both satellites. You need at least one reference carrier where you know the exact position where it's transmitted on the Earth, from where it's transmitted from the Earth, in order to calibrate the system and get a sufficient accuracy at the end. That's why we have recently introduced a new product, a one-satellite geolocation system, which will enable the satellite operator to localize interference by using just one satellite. It's a complete new approach compared to systems, compared to other systems on the market. It simply works by measuring the power of the satellite signal over a certain time frame and compare this power fluctuations with the interference signal. Because every satellite signal on the way to the satellite and down to the Earth is affected by power degradation caused by the satellite movement, the atmosphere, and the weather. And this is unique for each point on the Earth. So if you transmit a signal from one point on the Earth, it has a quite certain, it's affected by certain power fluctuations as compared to another point on the Earth. So it's like a fingerprint for the signal, as you like. And this gives us the possibility to localize interference by just monitoring the power of the signals over time. So that's a new tool which we have recently introduced on the market, but still that is not the end of the road. Yesterday we had a quite nice dinner and we have discussed several cases, and Andreas gave me an example of an interference issue he had recently where he could successfully geolocate an interference in 8 minutes. And this was not an easy one. As far as I understood, it was a tricky one because he had to apply some sophisticated algorithms like reconstruction, subtraction, whatever, in order to increase the signal-to-noise ratio of the interference signal and to improve the accuracy. But it could be done in 8 minutes. 5 years ago, it would have taken several days, maybe weeks, to localize this case. I said, okay, let's now imagine what can be done in 5 years from now on. And let me try to give you an outlook what can be done in the next years and what concepts we are working on. First of all, as we have developed our system, our geolocation system, the main intention was to fully integrate it with the carrier monitoring system, because the first issue you have is you have to detect the interference. Then you can start to localize them. So if you have a fully integrated system, the system by itself can detect the interference and can trigger the geolocation system to start the localization process. Currently it's done manually by the operator, but in the future we will try to automate this process. The only problem here is that if you're using a traditional geolocation system, as I said, you need the ephemeris data from the 2 satellites, you need the reference carrier. This information has to be added manually, usually by the operator. But now, fortunately, we have the SDA, the Space Data Association, which hosts a database where all this information shall be stored. So several operators are members of the SDA, and they will store exactly this information, the position, velocity of the satellites, reference carriers, everything what's needed by geolocation systems to do successful localization. And fortunately, also the new chairman of the SDA, Mark Rollins, is working on a concept that geolocation systems will get access to this database to import this information. So as soon as we have implemented this step, this interface, the system would be able to automatically start the geolocation process whenever the carrier monitoring system has detected a possible interferer, can automatically trigger to start the geolocation process. The geolocation system will then access the SDA database, get this information out of the database, and can do the localization process without any interaction of the operator. So we can assume a fully automated system, and it will not take another 5 years to do this, because the basis is there. We have all the stuff already in our system. It can be done quite fast. It's just a matter of implementing this interface and implement the automation process. So that would be, I think, a huge step forward, and also will significantly improve the success rate of localizing interference. Another thing our engineers are thinking about can be summarized under the modern term, big data. Currently, what we are doing is we are receiving the satellite signal. It's an analog signal. The first thing we are doing is we digitize it. So we're using a digitizer which digitizes the analog signal and gives us the samples. And all the rest is done in our software. So all the signal analysis, the geolocation, whatever, spectrum analysis, all that is based on these samples. You can also call it raw data from the signal. And we are already able to stream this raw data into the memory and further on to the hard drive of the computer. What we are now thinking about is, if we would have the processor speed and the storage capacity available, we could permanently stream this raw data 24/7 on a hard drive, and several hard drives for sure. That would enable the operator to store everything 24/7 on the hard drive. So he could catch, for example, if you are able to stream the whole L-band at once, he could store the whole L-band from all of its satellites in real time on the hard drive. So there will never be an incident, he will get lost. Everything is stored on the hard drive, and our system is able to take this data out from the hard drive, in a post-processing, apply the signal analysis and geolocation routines and do the analysis. So I think this is something which will take several years because we need this processor speed. We need the speed of the digitizers in order to be able to stream all this data in real time to the hard drive. We need the storage capacity, but time is working for us. Let's improve every year. Storage becomes cheaper and cheaper every year. So at the end, I'm quite sure we will have such systems in place. And so from technology point of view, all that is possible. We just have to put all the basic stuff we have already available today. We have all that to put together, and at the end we will have a system which can fully, in an automatic way, not only detect but analyze and localize interference issues. And I think that could be a major step.
No, thank you, Erwin. I mean, I think you're absolutely right. Things we're working on, this has come out of conversations, we've had this in workshops, this big data, and I mean collecting that data. Imagine that data, say Eutelsat's data, getting into the SDA along with Intelsat's data in some form. We don't even know what that might be. But we thought it was impossible that satellite operators would share ephemeris. It's not. It's happening because of the SDA. It's a big change. 2009, very key. I think because of that, IRG has been able to build on that. It was a key moment when the operators stood together and shared that information, because it's the data that gets us the answers we don't know we've got. We don't even know what that is yet. But big data systems are already here. And you've got to think of IBM and a few others. If we could share that, even our level 1 operators who have perhaps less experience, because they have a big data system, perhaps it will help them and they will be able to resolve quite difficult cases quickly. And anybody out here in this room or elsewhere who is either involved to buy or running a network of any kind that involves satellite transmission, you need some of the tools. You don't necessarily need these big tools, but you need some of the ones that Roger alluded to, and the monitoring. This is another big thing. You have to be organised. And you get that right at the beginning, you will have a successful network and you will manage it. And if you have those right packages together, you will be able to work with your own satellite operator well. You'll be able to share things and be able to fix things quickly. Because after all, you want your services to be reliable. You want protection. What we heard yesterday. You want all this. We have to get this together. And thank you. I think big data is it's a bit of a generalistic word, but it is the thing we don't have. But we do. It's starting with the ephemeris at the SDA. That's why I was interested about the EU Satellite Centre, but I don't want things going off at another tangent where we start having data elsewhere. It should be together. Maybe the SDA isn't the right place yet, but it's a darn good place to start, because all the major operators, when you think 3 of them are 66% of the world's geo-satellite system, at least, just with 3. It's a big percentage. Remember, they did this for conjunction analysis purposes, the insurance game. We don't want to crash into each other because we're starting to move closer and closer. You saw the pictures yesterday about our globe, how busy it is. You heard Roger say we can get 1,000. I don't know where they're all going to go, but I guess there's a place up there for them. Andreas, can you tell me the story? How many years you've got to wait for that next interference? 3.8 years, did you quote yesterday? Can you recite that small story?
Yeah. There's a problem between some capacity in S-band, which we have sold to EchoStar on our 10-degree satellite, and we had an interference case with a remote sensing satellite operated by the European Space Agency. And it was passing through next to the beam towards the receive station. And as it is a low Earth orbit satellite, It rotates in synchronous orbit, 98 degrees inclination, and passing through the beam from our satellite towards their monitoring stations is always changing, because the orbit of that lower satellite is always having the same regression of the ascending node, and so orbit parameters. Sorry if I overload a bit. The thing is, we calculated that to foresee when there will be the next interference case, and we found out that the next passing through our beam and their orbit towards their monitoring station is happening in 3.5 years.
So he's put that in his Outlook calendar so that he knows where to deal with that one. Of course, if you extrapolate one incident by thousands of satellites, then perhaps that type of calculation is part of that next process, what we should be doing about working out when the next interference, it's sort of that word predictive. You start to predict the next problem. So instead of being surprised you're ready, you may even move services so that it just never happens. Services are never affected, because certain things are going to happen. We can't stop everything. I think one of the facts, I've got some other graphs here, now I'm going to move quickly on to Terry in a minute. And Terry, I think I'd like to move us into carrier ID and start from about that point, because I think it's a great point to bring that in from there. But what we want to do here is just focus on the fixing of interference and using these tools and sharing this data. It's probably the biggest thing I can say here is that we have to work together. We cannot be individuals about this. It's complicated out there. But wouldn't it be marvellous if you actually knew when the next guy was going to do it? You could manage that. Once you know what's going on, you can manage it. It's what management systems do. So I'm going to slide on a little further now and introduce Terry. And again, Terry, we got some geo slides here as well. But I'm going to move us into let me just, dear old carrier ID. So let's move straight to that slide there. And Terry, take us into the carrier ID purposes, where Zodiac is, and probably following very similar lines to Siemens and Erwin. So take us there, please.
Okay. On the previous slide, what you had is several scenarios of interferences. But for us, as an engineering company, everything can be interferences. For an operator, it can be interference. For us, it's just a carrier. And behind the carrier, you have a transmitter. Okay, so what we do, we locate those transmitters. We monitor those transmitters, carrier, to make sure of a good quality of service. So first of all, we use a CSM system. And as Erwin was talking, in CSM is common system to monitor your carrier. What we introduce in CSM is a trigger on events. So you can record, you can geolocate, you can analyze your carrier, you can even demodulate those carriers. So this is monitoring parts of it. So I'm sure you are well aware of this. What's new and is great, brilliant idea is a carrier ID, which solves everything. If everyone had this, it will our world will be much easier. Daily tasks will be much easier too. So sIRG is very well involved in this, and Martin spent a lot of time. So carrier ID is a spread spectrum below the carrier, so it doesn't take that much energy on your transmitter. And inside you have coordinates of the location. You can put a message, and so you'll see. So this is a standard carrier ID with a simple carrier with its carrier ID inside. We can demodulate those carrier ID, but you could also have, on next slide, I believe, you could always also have this carrier very low below at the noise level. So we could also demodulate this type of carrier ID. Next will be a carrier ID jamming another carrier above the carrier. So this works also. Next will be below the carrier. It will work. And the last one will be two carrier ID jamming each other. So we could demodulate both carrier ID. And at the end, what we have from carrier ID put in the air, up in the air with Eutelsat and ACS, we could find those information. And in the information, when you demodulate those carrier ID, you find the big carrier ID, and also you can put coordinates of the transmitter and a message. So this is a very brilliant solution we could give you, and it goes very far in the process as we give you the position, but also coordinates of the transmitter.
And can I add there, I think there's an interesting spin-off with carrier ID. The carrier ID itself is what we were thinking about, but people like Siemens and Zodiac, because of working on carrier ID and detecting it, has actually improved detection algorithms because it, it was tricky. It's timing, speed, there's all sorts of things going, and that's leading us into areas of getting smart with suppression of systems, starting to think about looking at the receivers, about smart filtering effectively by, digitizing that whole link down so that you can now start to actually, who cares? You've got a jammer or whatever, the signal still comes through. You just eliminate it. It's funny how one small subject starts to lead technology and the inventions, moving on. But just an aside, that what carrier ID we started as has actually led to more technology, to more solutions based on just that one subject. What I'd like, Terry, is I think it's time to get into geolocation itself. So if you'd be kind enough to get our audience into the tricky subject of geolocation, since it's the hot topic.
Okay, so in geolocation, as I say, so the scenarios we've taken is a fiction. Okay, we don't know if it's interference or not, but just a fiction. You had this transponder on top, and from those carrier, we try to, it's real cases, but we don't know if it's interference or not. So we can imagine being, of course, under the coverage of the satellite. It's different countries, and you monitor this satellite. Then carriers come up. You want to geolocate. You will need, as Erwin was saying, in standard, I would say, geolocation system. You need a mirror satellite, means a nearby satellite. We're talking about a 10 degrees separation. And you will need a reference carrier, which is a known carrier transmitting onto that satellite, in order to compensate unknown parameter on board of the satellite, like a local oscillator, drift, and so on, phase noise. So this allows you to locate with a good accuracy, in case you have good ephemeris data, the transmitter position. So in that case, we are quite lucky. There's next one. Oh, sorry. Previous.
No, do you want to backwards or forward?
Okay. Backward, please.
There we go.
Okay. And this one, we had no carrier on the mirror satellite. So you can detect easy and locate your carrier with good accuracy. As I was saying, we're talking about less than 10 kilometers. If you have operator accuracy, ephemeris accuracy, it can come down to 1 kilometer. Yeah. Next. Okay, this is one of the cases. Of course, it depends, as always in geolocation, of your satellite configuration, the sensitivity, if your satellite is inclined or not. This is a difficult case, as both satellites are very stable, but still we achieve good accuracy. Next scenario is much more complex, I would say. As on this transmitter, on a mirror satellite, you have a carrier. And there is a transponders missing on the slide. But on the mirror satellite, there is a carrier. So what we'll have to do to have a better detection, you have to cancel the carrier on the mirror satellite. So you will detect better, but also you will have no ambiguity. As the system is fully symmetric, you detect both mirror and satellite main satellite carrier, so you will have two positions. So